Okay, we need to prove by induction that 1 plus 2 plus 3 onward to n is equal to n times n plus 1 over 2. What we need to assume is assume this to be true and then prove the identity. So we consider the base when n is equal. So if n is equal to 1, then we'd have here that 1 plus 1 is equal to 2. Now we need to do the inductive step. We assume that based off of this, our statement n plus 1 over 2 is the sum of all numbers from n equals, we'll say I equals 0 to infinity, sorry, not to infinity, to n of I is true for all, and they must be positive. So all positive integers, this is true. We assume this statement is true. This specific statement is assumed true. Now we show that this assumption holds for k plus 1, right? Because if it applies for k, right? A k is this value here, right? Some random value that's an element of the positive integers. Then it must follow for k plus 1 or the next positive integer. It doesn't matter what it is, it just has to hold for it. So we need to prove that k plus 1 is equal to 1 plus 2 plus 3 plus k plus k plus 1. What is the same as saying, right? This should be the same as k plus 1, 1 plus 1, which we'll write as 2, over, and just recall that I got this from this here. So I just plugged in k plus 1 for our k value. What can we do from here? Well, what we can notice here is that this part here does not only resemble, it is exactly the statement we assumed to be true. Is equal to k, write at that in purple, k plus 1, k2. Tool to prove this is the algebraic step. For this algebraic step, we need to show that this statement here that we just proved to be true. Like, we know this to be true. Actually, no, sorry. We know the blue part to be true. We need to prove that the entire statement is true. So we need to prove that, well, really all we have to do is just consider this portion right here. Well, we need to prove that this statement plus its successive inductive statement, k plus 1, is true and equal to our expected value of this. So for us to do that, we just get a common denominator. Like, all we are attempting to do is make this entire side look like this side. That's your entire goal. So we write that as a common factor of both. We get the k plus 1 times k plus 2 over 2, our original statement. Thus, by induction, we have proved that this is true for all positive. Though we had assumed some value k for a successive inductive step, this still applies. Hopefully that helps.